In this tutorial, we're going to use molecular dynamics to explore the collision between a molecule A and a molecule B. The collision might be elastic, or it might be a reactive collision, depending upon which molecules we choose, the velocity of collision, and so on. What we need to do is, first of all, create a couple of molecules. What we're going to do is create a nitrogen with a double bond, and then a fluorine F2. So what we've got here, if we build these things, we have n2h2 and F2. Now we need to separate these for the collision. Let's select the F2 and move it away a bit, like that. And we're going to collide F2 with n2h2 as the target. To do this, what we need to do is select the n2h2 and name that selection point. What this does is make point the center of mass of this selection, or of the n2. So the center mass is right here. And what we're going to do then is take the F2 and give it some velocities towards the n2h2. That is, we set the velocities, and let's use 150 angstroms per picosecond here in the direction of point. That is, in the direction of the n2h2. So we're going to set these velocities, and we're ready now to go. First of all, however, we need to figure out which procedure we're using. We're going to use CNDO, a simple semi-empirical method, and we're going to use UHF because we may have some open shell products in this reaction or in the middle of the reaction. So we need to use an unrestricted Hartree-Fock description. So finally, we just turn on molecular dynamics. We use the restart button, which means that we're going to use the velocities that we just gave it, that is the current velocities, rather than some equilibrated velocities corresponding to 300 degrees Kelvin. So we just turn this chemical reaction on and see what happens. The F2 comes in and collides. We may hit the space button periodically to see what's going on or to send it to the display. The thing is colliding. Not quite sure what's happening at this moment. We seem to have n2h2 in a cis sort of conformation rather than in a trans. The fluorine seems to be associating with the n2h2, and if I'm not mistaken, what's happening is that the H2 is going off, and we now have n2f2. We still have the same bonds because we haven't changed the description of the bonds, and now it looks like the H2 is not associating but going off by itself. Let's see. So yes, we did not get H2. It dissociated into two hydrogen atoms, apparently. So we have two hydrogen atoms and n2f2 apparently. Let's stop this trajectory. What I want to do is run a script here. There's a script command called rebond system, which takes the distances that we have and redraws all the bonds. So what we have is hydrogen atom and another hydrogen atom in this thing in the middle here, which we'll take a look at, as seems to be N2 and F2. Now, what I think I need to do is to, let's see, we get rid of the hydrogen atoms, clear those up, and let's optimize the rest of this system. See what we've got here. Okay, that's now optimized. Let's run our rebond system again. To rearrange the bonds, and what we seem to have is cis n2f2 as a product of the reaction plus two hydrogen atoms. So that's a chemical reaction studied by molecular dynamics.